So today, I will tell you how to create a Lego explosion using only Blender. Let's get started. First, set up an explosion you like. There are many tutorials on YouTube how to do explosions with Mantaflow, so I will skip this part. Just make sure that you save the explosion cache in a location you will find later. Also, make sure that the simulation is saved in the OpenVDB format. Next, set up a new and empty Blender file with the settings you like, such as render engine, FPS and resolution. Now, import the fluid data of the explosion you just created, or any other explosion. For this, press Shift-A, Volume, and import OpenVDB. Select the cache data for all frames and confirm. Center the explosion in the origin point. When you look at the object data properties, the fluid data contains different attributes of the simulation, such as density, flames, temperature or velocity. We will come back to those later on. Now create a bounding box around the explosion. I used the extensions of the smoke domain I created earlier. Create a new collection for the remesh functionality. Add a mesh, for example a cube. Name it Fluid Fire Remesh. Apply the volume to mesh modifier. As object, select the fluid data object. As I told you earlier, there are different attributes saved within the fluid data. For our fire remesh, we want the flame data, so we type flame. For our Lego explosion, we want a constant voxel size. With the default value grid, you can't really control that. So we select the resolution mode voxel size. Now we can see that each voxel keeps its size relatively constant. You can update the value of the voxel size later if you want. If you want, you can also add a second mesh for the smoke fluid. I set different display colors, so you can see the two meshes. Next, we want to remesh the fluid into cube shape. For this we can take our fire mesh and add the remesh modifier with type blocks. At first, it does look good. But if we go through the animation, we see the problem. The size of the cubes changes throughout the animation. The way the Blender remesh works, is that it calculates a bounding box around the mesh. Next, it divides that bounding box into small cubes depending on the octree depth. So the bigger the bounding box is, the bigger one single cube will be. Since this is not working the way we want, we can delete the remesh modifier for now. Instead, create a new collection. We call it Cube Remesh. We duplicate our bounding box from the fluid data and move it into the new collection. Next step is, we decide how large we want our bricks to be in the final result. For this, we add a cube, name it Lego brick and go into edit mode. We add a circle, scale it to 0.8 and move it to the upper face. We extrude it by 0.25 along the z-axis, fill the top face of the circle and exit edit mode. We now have a simple Lego brick, we will later use for remesh. Now we scale the brick to the size we want it. Consider the explosion size and detail for this. Apply the scale. For the next step, duplicate the bounding box and call the second one extended bounding box. Apply a remesh modifier and select blocks as remesh type. Deselect remove disconnected. Increase the octree depth, so that the remeshed blocks are slightly smaller than your Lego brick. Now in front view, go into edit mode and scale the bounding box in X direction, until the remeshed cubes have the same size as your Lego brick. You can also play with the remesh scale for fine-tuning. For the next step, we split the mesh into a left part and a right part, keeping the outer faces on the left and right untouched. Make sure that the created mesh does not overlap with the fluid bounding box. We can now delete the remesh modifier of the extended bounding box, but remember the settings for later. Next, duplicate the extended bounding box and call it cubed fire remesh. Delete the remesh modifier if not done earlier. Add a boolean modifier, set the mode to union and the solver mode to fast. Otherwise it will take some time. Now select the fluid fire remesh. Next, add a remesh modifier and set it to blocks. Uncheck remove disconnected and use the settings you used earlier for the extended bounding box. If we go through the animation now, we can see that the remeshed blocks always keep the same size. The reason is the constant bounding box of T-mesh because of the extensions we created earlier. To remove the extensions, we add another boolean modifier. Set the mode to intersect and the solver to fast. Then select the fluid bounding box as object, so only the blocks within the actual explosion remain. One thing to consider, this whole process is not the fastest, so if you want a higher resolution explosion, Blender might take some time. Now the last step to do is replacing the cubed mesh with our actual Lego bricks. For this, we select our Lego brick and, while keeping Shift pressed, select the cubed explosion. Press Ctrl P to parent the brick to the explosion. Now select the explosion and go to the object properties. Under instancing, select vertices. This results in bricks being created at each vertex of the explosion mesh. Deselect the Show Instance as Selections, so you only see the Lego brick explosion. Now you have an explosion animation with Lego bricks inside Blender. You can copy the workflow for the smoke mesh as well. Remember, you need a new Lego brick and parent it to the smoke mesh. The finishing steps will not be covered in detail in this tutorial. Set up a material for your Lego bricks. Unfortunately, you cannot access the fluid attributes from inside the Lego material, so you have to manually define the color shift from yellow to red for the flames. For my explosion, I use the distance from the center of the explosion to color my bricks from yellow to red and also define the emission strength, as shown here. You could do the same trick to the smoke as well. I just mixed a gray shader and transparency using a layer weight note. Set up the camera and add a background, for example an HDRI from HDRI Haven. There you go.